All right, it's that time again. I'm going to let people come on in, give them a chance to log in to the stream, grab some Coke on the way in. Oh, I guess I can't say that. Product placements and all. Liquid motivation. All right. Well, let's get the show on the road. Good Friday, everyone. Welcome to another episode of Houdini Secrets Live. My name is Chris, and I will be demonstrating some Houdini cool stuff for you today. And today we are going to be going over some advanced digital assets today. Houdini Digital Assets, if you haven't had a chance to play around with them, are really, really super powerful, and they're really a kind of an institution in the world of CGI, and they're really kind of revolutionary. But they're really easy to operate on the surface level, but there's a whole bunch of really, really fantastic stuff to do on the advanced level. And today's lesson, we are going to be talking about just what to do with the Houdini digital assets, just with Python. So what we're going to be doing on today, we're going to be covering kind of like five different things dealing with Python and digital assets. So the first thing we're going to deal with is Python modules inside of a digital asset. Everything is about Python modules and HDAs, so they're kind of like naturally built for each other. Then we're going to deal with events. And events is kind of like when you create a digital asset or you close a digital asset, you connect a digital asset, you change it, or whatever. Every time that happens, the triggers an event. We're going to talk about other modules. So you can store a whole bunch of modules, Python modules, and other modules for that matter, inside of the digital assets. We're going to be talking about callbacks. Now, every time you do something on a widget, like a button press or a radio box or a slider, you can trigger a callback, and you can have that driven by Python script. And we're going to be finishing off with variable menus. Now, variable menus are a way of creating a dynamic user interface that can change over time. All right, and I'm going to do my best to go over, and I see you folks on here, and I'm going to try to keep on looking over to my chat screen to make sure that things are going. And so therefore, hang with me. If I don't catch you right away, then we will try to make sure to get a hold of your question. I'm going to try to do my best to read my chats. They're kind of like in the side window, so if you see my checking my head, I'm looking over that. I got to come up with a better system, move my monitors around. All right, so let's get this show on the road. I'm going to transfer things over to my Houdini demonstration window. And okay, there we go. Now I am starting with a brand new raw version of Houdini. And this is my setup. Now your setup may not look like this. Your setup probably looks something like this by default. Where's model? Okay. Yeah, it probably looks something like this. I have a desktop pre-created here that I've got on here, and this is my empty window here. This is my display, and here I have a Python shell. Since we're going to be dealing with Python, we're going to be typing in the Python shell a lot, and so that's why we've got this here, so that we can have something to type with. Okay, so we're going to start things off, and we're just going to create an empty digital asset. We don't have anything to show, but that's okay, because that's all we're going to do is play with Python for it. So I'm going to create a digital asset. I'm going to just go right here and drop in a subnetwork. So I've got my subnetwork in here, and I'm going to call this HSL demo. Houdini Secrets Live demo, in case you didn't figure that out. Okay, now we're going to turn this into a digital asset. I'm going to right click on this guy and hit the create digital assets. And we should come up with a little window here. and I'm going to just get rid of my prefix here. So the operator name is HSL demo, and the operator label is HSL demo. I'm going to go ahead and capitalize the D for demo, and I'm going to leave my default location to the library just like that, to my OTL library. I'm just going to click accept, and that should give me a type properties window. All right, very good. All right, so nothing's going on here. So we're going to start right off, and we're going to whoa, hopefully everything is okay. I've just lost everything. Bring it back. Okay, come on back. Is this still going? Okay, good, 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 good. I lost my stream there for a second, folks. Thanks for your patience. All right, I'm going to click on the scripts tab right here, and make sure that the scripts, where it says event handler, go to where it says Python module. Make sure that it says that, because if it doesn't say Python module, you want it Python, and they edit as Python. Now you can create H scripts inside the Python module, and that just gets confusing. So make sure that the edit as is Python. So you've got Python module in the event handle and edit as Python right in here. So what we're going to start off is we're going to create a very simple Python function. And we're going to say def, where am I? We're going to ask the question, where am I? Where am I? And I'm not going to set any parameters to it. Finish it with a colon here. And then I'm just going to type in this, location equals who.pwd. Okay, so let me explain what this is. Who is the Houdini Python module library. Now, since it's in the digital asset, the Who library is integrated by default. Now, if this wasn't here, and actually we can do this here, we say import Who, and so what that does is it imports the Houdini library. This statement isn't necessary because it's a digital asset. The Who library is loaded automatically, so we don't need to worry about it. So I'm just going to go ahead and get rid of that, and just to avoid any kind of confusion, because it's not necessary. And PWD. Now, in case you didn't know what PWD is old-fashioned Unix. Houdini used to be originally a Unix program way back in the days of yore, and PWD stands for Print Working Directory, meaning display where the current location is. And so what we're going to do is we're going to call the Houdini library and say, okay, where am I? And then that's going to pass on to the location variable. So let's print this guy out. So go print, I am located at, okay, open and close parentheses, dot format, location. Okay, I'm just going to hit apply, and voila. Okay, so what? Big deal. We've got a digital asset, and it's got some Python code inside of it. Okay, that's kind of like inconsequential. So now we have to figure out, okay, we've got some Houdini, we've got a digital asset, and it's got some Python code inside of it. So how do we access it? So I'm going to put this off to the side a little bit, so it's right there. And so we're going to go off into the Python shell window, and I'm just going to tell you that there is a Who function, in the Houdini asset called HDA module. And the HDA module gives access to this. This is the basic component, or it's a separate element of the digital asset called Python module, and we have to have access to it. So let's go ahead and give it. I'm going to hit accept just to move this out of the way. So I'm going to say foo equals, and now what we need to do is give foo the value of this node. Okay, this node has a location on here, and It's just sitting right here, but we don't know where it is, and I don't want to type in all this because I'm lazy. So I'm just going to grab this node here. I'm going to put it right over there and hit enter, and I say foo equals who.node obj HLSL demo. Okay, that's all good and fine now, but what do we do with it? Well, what we do is foo is now a pointer to this guy. So now this variable foo now has access to all those things good and wonderful inside of this digital asset. So we're going to call the HDA module and say, okay, where am I? So we're going to type foo dot HDA module, and look at that, Houdini's filling this auto completion for us. Okay, so now we have the access to the HDA module, and then we say, all right, where am I? Okay, I'm going to hit enter. Uh-oh, it says I spelled it wrong. Look at here. Here's the error. It says attribute error. Module has no attribute. Where am I? Okay, I misspelled that wrong. So I'm going to upspace that, and it's going to, and I should put an E right in there. Now let's hit enter. Oh, it says no attribute where. What do you mean it has no attribute? Let's go to the type properties. And oh, look at that. I misspelled it wrong. It says where am I? I just have a lowercase I in there. Okay, now I'm going to click apply, and we're going to leave that here. Let's try that once again. Ah, the wonders of live entertainment. I'm going to hit enter. There it is. It says, I am located at slash. You're going slash? What's the big deal? That's like not good. I'll explain what the slash means in just a little bit. But that's exactly what we should be getting. Okay, so we're in the shell, and we've got the HDA module here. And so there's a bunch of various ways that we can access this. I'm going to close this up again. Now, what we did was we dragged this actual node onto here. Now, this is not the only way that we could do this. We could return a node type for Houdini. So if I say NT, and that's short for, be short for node type, we get node type equals who dot node type, and there is our function right here. Okay, what node type does, it basically returns an abstract pointer to whatever we ask for. So we're going to say, okay, give us the node type or a pointer to this node right here. So we have, I'm going to put open single quotes, forward, obj slash HLSL demo, close quotes. And you see, it didn't complain. So it said, okay, I know what you're doing. And if we want proof, all we have to do is say nt.path, and it will give us the path of that node. Oh, nt, okay, I'm just going to leave that there. But we do have access. Well, let's see. Let me make sure that we are even with a print nt. Okay, so it is HSL demo. Okay, so it's just not pointed right. But NT does have access to the HDA module. So let's test this out. NT dot HDA module, open and close parentheses. Where am I? Okay, I'm going to hit enter. Oh, I misspelled it again. But I must have a trigger finger on these eyes or something. Okay, I am located at that. Okay, that was cool. But on the original example where we dragged and dropped the node on there, and this is where we actually type the node inside of the node type here, that's because we actually had an actual instance of the digital asset sitting inside of our OBJ. Now, but what happens if we wanted to access a module inside of a digital asset, but we don't actually have an instance available? So I'm going to go ahead and deal that. So what we can do is we can access the on in disk definition of our digital asset and say, okay, give us your information. So a lot of that is accessed in the exact same way. Let's call it NTC for node type categories. So NTC equals, now we're going to start it off with who. We're going to start off with node type again. Now I'm going to put open and close parentheses in there. But instead of putting the path of the instance digital asset, I'm going to call another Houdini function called who.obj node type category. So who.obj node, and oops, this went right to it. So I'm going to double click to complete it. And I'm going to go open and close parentheses. Now this is going to return a pointer not to an instance, but it's going to return a pointer to the actual memory definition of where this digital asset is actually kept. And so we called this HLSL demo, right? That was the name of our digital asset. So we're going to call, okay, give us the name of the digital asset, and we call it HSL capital demo. All right. So hopefully that is complete. If we're going to hit enter, okay, print NTC. Okay, print NTC. Thank you. None. Okay. HSL demo, and maybe I spelled it incorrectly. So let's go and get a digital asset, HSL demo. And let me pull up the, oh, look at this. I spelled it wrong. The S and the L are not capitalized. So I spelled my thing wrong. If we go to the type properties, we can see here the operator type is HSL demo. And so actually, it's not uppercase, it's all lowercase here, the operator type. So therefore, we have to call it the lowercase. So let's call this up again. And then where it says HSL demo, let's put it all caps. HSL demo. Hit enter, and then print NTC. And there we go. We now have a pointer to the actual location inside of memory of where this digital asset is kept. And now we can call the NTC, where am I? NTC HDA module. You know what? I'm sick and tired of typing HDA module. I'm a slow typer. I can only do my front fingers, so I'm pretty slow. So there, Houdini provides us a function, and if I can remember it, let's see if it should be HM for Houdini module, lowercase hm, and say, where am I? Hit enter. Attribute error has no HM. So is it HM, capital M? No, I don't think so. I can't remember what it is. Okay, we'll come back to this. Maybe I have it somewhere in my notes and we'll have it, but it will go into the who module. Where am I? All right, we're going to hit the enter here. It has no attribute. Okay, so what did I do wrong here? NTC, NTC. All right. Oh, it's not who module, it's HDA module. Okay. HDA module, it just goes to show you that even if you've been working with this stuff for a million years, you still forget how to spell and you forget the names of things. So it's all very common. There we go. I am located at there. Okay, I am located at slash. Okay, but you folks might be going, okay, what's with the deal with this? What's with this slash business? Well, if you guys grew up in the Windows universe, you probably never had exposure to the root. And you're going, root, what the gunny go is the root? I'm going to close this. Say unlock and save. Yes, we go that. Okay, The root, notice here where it says /obj at the top. Now, if we come over here to the different Houdini modules, if we click down on that, we can choose a chop network, an image network, a material network, object network, whatever, all the way down the line. Okay, but what does that mean? Is they're all at it? If I just type in the word who.pwd right here, it says we're at /. Okay, / is the root. That means in the Houdini object filing system, / is the top folder. And so therefore, since we don't have any kind of anchor and since we don't have any kind of reference, what we did was when we called where am I, we gave it no kind of frame of reference or location. So when it said I am located at /, of course it located at /, so that's all it created. So let's go ahead and create a different function that actually tells us a little bit of location so we can focus on what to look at. So I'm going to create a new function here because I'm going to say def, and I'm just going to say crag. Okay, no input, no for that. I'm just going to put crag, open and close parentheses, colon, and then I'm going to type in the word top. Top equals who.node, and inside of, who.node, I'm going to go ahead and type in open quotes /obj, close quotes, like that. Okay, so when I execute that, top is going to give us a pointer to the object node. Now the object folder is where all the objects go. That's where you put your lights, you put your characters, you put your cameras, everything goes in the /object node. Now if you're creating chops or PSDs or LOPs or any of those, then you would go into those LOP networks, but we're working in the object network, so we go on to that. But now since we have access to this top node here, we can start doing stuff. And one of the first things I want to do is I want to create a brand new geometry node. So I'm going to go and say, okay, I've got top here. I'm going to say top.create node. Top create node. And when we use create node, we have to tell it what we're going to create. And so give me a geo node. Okay, geo is the Houdini name for geometry. You know, that was a mental straight there. And I'm going to give it a local name. So I'm going to call it crag geo. Crag geo. All right, so I'm going to just hit apply here. And I'm going to click accept. So, well, I don't know that it's going to work. So I'm going to go ahead and leave that there. And so here we go. I think I'm still, does NTC still point at that? So let's try to see if NTC is still pointed at it. So NTC HDA module, where am I? So instead of where am I, I'm just going to call crag. All right, so I'm going to hit enter. Okay, and it created a geometry node right here for me automatically. Okay, so we have crag geo. All right, now if we double click the geometry node, there's nothing in here yet. Okay, so that means we have to go back and put stuff in there. So I'm going to go ahead and delete that. So let's go ahead and put some stuff in it. Oh, snap. My window has gotten outrageously long. And hopefully it's, I might have to restart my Houdini very, very, very soon if things don't work very well. But, okay, so I've got the top created, and I'm going to set this to a variable name. I'm going to just call this geometry. Geometry, spelled correctly. All right, so that's good. So we have the geometry node pointing now to my geo node. So I'm gonna go crag equals geometry dot. We're going to do the exact same thing. We're going to be inside of the geometry node, And so let's go create a brand new node. So create node. And what I wanted to do is drop in some test geometry for the crag. So test geometry underscore crag. That was surrounded by quotes. And then locally, I'm going to call this guy crag. All right, so this is going to do this. And now, just as for bona fide proof that things are working well, let's give a little print statement. So print crag is located in, and we put the open and close curly brackets, close quotes, dot format, and open and close parentheses. I'm going to do crag dot path. Okay, so now we're going to click apply, and then we're going to call crag again. All right, I'm going to hit enter. Oh, and there's crag. All right, very cool. Click accept. All right, so we've got the crag geo here. I go inside of that, and there's crag ready to rock and roll. And as you all know, if you animate crag, crag walks over, and he pulls out his hammer, and he does his best John Henry. And I always wondered if, you know, he also had that tune of the Beatles of Maxwell's Silver Hammer swinging in his head. All right, there he goes. Cool. All right, so our system works. Yay! All right, there's big celebrations. Okay, now we've got a location. So what if, you know, we want to have a callback here? So what happens if we wanted to go and create this, not when we go through all this kakamaka, calling up the type, the node type and the category and the HDA module. What if we didn't want to deal with all that? We just wanted to do this on created. So as soon as the node is created. Well, Python, I mean, Houdini, the digital assets, provides a whole bunch of things called event handlers. So if I click on the event handler where it says Python module, I'm going to look over to here and look for what I'm looking at. A custom script. No. On created. Okay. I'm going to click on created there, and then we have a blank window, and this is edit as Python. So what this is a kind of like little baby, Python module or Python function embedded within the digital asset, and now we can type a function into it. And so I'm going to type this in here. Quargs, open and close square brackets, and inside of that I'm going to go open single quotes, close single quotes, and I'm going to go put in there type. So basically I put the word type in here, and you're going, I don't know what this quargs means, but I'll explain this in a little bit. But quargs is kind of the same way, is kind of the same thing, but a shortcut to all this node type and HDA module business. So quargs, and we're going to use that as an index for type. We're going to go HDA module dot crag. Okay, with that done, I'm just going to go ahead and hit accept. And with that, I'm going to get rid of that node. So nothing is in here. So what I'm going to do then is just pull open, right click my tab menu, I hit digital assets, I'm going to choose HSL demo, click that, drop it in there, and it created a crag for me automatically. And so it's exactly what we expected to do. So let's go back and take a look at what was in that callback. All right, so on created says quargs, and the index to quargs, it's looking for a list. Actually, quargs is a dictionary, and it's saying, okay, give us a pointer to the HDA module, and that's what it's doing, the HDA module there. And then he's saying, okay, call crag, which is listed here in the function module. It's listed right there. And it has the full location of where crag is located, which is down there. So that is all good. So you're probably going, okay, I'm with you so far, but I'm kind of lost with this whole quargs business. Now, quargs is it kind of took me a while to figure out what quargs was, but quargs is a Python functionality called keyword arguments. And what quargs is that when there's an event handler in an environment, then it puts certain global variables from the event handler inside of quargs. And quargs is actually a dictionary. And this dictionary stores all of those global variables that you want to create. And one of those global variables just happens to be the type variable, which is a pointer to the actual type node itself. So there we can have that. And so you're saying, okay, if this is a dictionary, where's all this located at? Well, let's go ahead and take a look at this. So what I'm going to do is just put in a print statement, print quargs node, close parentheses. Okay, and so what we're going to do, here's another variable inside of that, the node, and so we want the full path of where the instance of this digital asset is located is. So we're going to put quargs index with the word node, and then we're going to get its path variable. Okay, I'm going to click accept. Yes, unlock and save. All right, I'm going to get rid of everything. I'm going to recreate. I'm going to make sure that my Python window sees some good stuff here. I'm going to right click in there, Digital Assets, HSL Demo. All right, so there's crag is located in there, and so obj HSL Demo 1. This is the path of the node that called our crag. Okay, cool. So that's what things are going. Okay, so if we wanted to, what are some of the other things that it could choose? Let's see. Let's take a look. How are we doing on the time here? Okay, yeah, not bad. Damn, look at that. Okay, I am going to go and restart my Houdini because my window is just freaking out here, and I have not figured out a way of resetting this. So I am going to go and call my Houdini again. So I'm going to close this. Okay, discard and quit because there's nothing on there to begin with. Okay, click Houdini. All right, it's coming up. While it's coming up, get some liquid motivation. Okay, we are back. Thank you for your patience. I'm going to return this to my TA Python demo. Okay, so what we did here was the digital assets. I'm going to call HSL demo, and just by adding it in here, there's the crag all ready to rock and roll, literally. Smash some rocks. So let's see about this quargs business here, though. Type properties. Now, if we go into the scripts, go on created, there's quargs, and it's printing out the path of the node that called it. Okay, but what if we wanted to print out what quargs actually contained? So what we have to do here is, do I have an example set forth in this schedule here? Okay, yeah, we could do this. Okay, so what we have here is, so suppose we wanted to know what all quargs contained. I'm going to get rid of this. And I'm going to say my quargs are, so print, inside quotes, my quargs are, put a colon here. All right, and then I'm going to, first I want to know how many quargs there are, because I don't know there. So I'm going to say num quargs equals the length of quargs. Okay, so the num quargs equal that. Oh, wait, this is not correct. There we go. Single quotes, single quotes. Okay, so this is returning the number of entries inside of the quargs variable. So we're going to go for I in range num quargs. Okay. So what this is going to do, range num quargs is going to recreate a list going from that goes from 0 all the way to the number of quargs, and that is going to be embedded in the iterator called I. And then we're going to say print, and then I'm going to put single quotes here. Now I'm going to put a /t, a \t. Now what that means is a tab. And so, okay, we've got the tab here, and so I'm going to indent the output by a tab length. And the \t is, once again, old school Unix. So we're going to go key. So we want the key, colon, okay, open and close curly brackets, and then \t, so tab, and then value, colon, open and close squirrely brackets, close quotes, dot format. And I'm going to make this a little bit bigger because we might run out of room here. And so for the first thing, I want to put in the key value. Okay, which value is key? Because it's a dictionary. And a dictionary, of course, is key-valued pairs. And so we're going to go quargs dot keys. So what that does is it returns all the keys inside of the quargs dictionary. And we want the ith key for that. And likewise, we are going to get the value, the ith value. So I go quargs dot values. Okay, that's going to return all the values inside of quargs, but we will only want the indexed one, the ith one, to go to that. Okay, so we're going to print all the values of quargs. I'm going to go ahead and click accept. Yes, unlock and save. So that's a problem here. When I keep on destroying these digital assets, I have to unlock and save every time I want to save, but that's okay. So I'm going to go ahead and click this. Come on, come to Papa. Digital Assets HSL demo. All right, there it says my quargs are key node, and there's HSL demo, and type is val node, which means this is a pointer to the node type itself, which is of type HSL demo. So those are the two keys that we're dealing with. Okay, well, that's good to know that whenever you have the callback, then you have at least a. Now, some of the other nodes that might be in there are, sometimes there might be, if depending on the callback that you're dealing with, you might have the old name, because, sometimes there's a, if we look over here, some of the events, other than uncreated, there's like on name change. So the old name would be in there. The input index upon input change, what the input index actually changed was. The current version. If you are dealing with the versioning, what the current version and the old version are on that. But for uncreated, it only gives us those two quargs, and so we have to bear it and like it. All right. So that is a way of creating a Python script for every one of these events happening inside of the digital asset. But what if you're saying, okay, that Python module is cool, I guess. Okay, but what if I don't want to use the Python module? What if I wanted to create a new module just for creating the squab? Okay, you ought to have a squab module. Okay, let's create a squab module. Everyone knows the squab. It's like kind of looks like Squidward in kind of like a shrimp kind of sort of way. It kind of looks like a crawfish. Get out your crawfish etouffee. All right, in order to do that, what you have to do is you're going to create it as a subsection of the Python module. You're going to create a submodule. And you're going, I don't know, you're talking kind of funky again. But what's a submodule? A submodule is just another way of using the Python-ness in order to redirect to the right place. So we're still going to access through the Python module, but we're going to call it a submodule. And there's a bunch of different ways of doing this. And we could ask for a custom script. We could type in a section name on here. But because I know that this is something extra, I'm going to come over here to extra files. And then I'm going to type in the name squab underscore Python module. Okay, squab Python module, that's what it's going to be. That's the name, and I'm going to say add empty section. Okay, what that did is that created an extra file inside of the digital asset, actually opened up a chunk of memory and said, okay, program away. And it made this file available right here. Now, what I'm going to do is I'm going to say, create a new function. And I'm going to base this function on Crag, but I'm going to use different, different coding. So I'm going to copy that, and I'm just going to type in def make me. Okay, so there's a call to make a squab. I can say, okay, just make me. Okay, I'm going to hit, okay, we're going to call it the exact same way. Top equals who.node obj. The geometry, top node, create node. And instead of CragGeo, I'm going to call this SquabGeo. And then I'm going to change this name here to Squab. And we're going to create node, test geometry. Instead of Crag, I'm going to put Squab. And for the local name, I'm going to put Squab. Oh, let's go, let's call him Squidward. Okay, everybody loves Squidward, right? Okay, we've got the make me function sitting inside of our extra module. Okay, things are getting a little bit harebrained. Okay, yes, unlock and save, save. Yes, okay, it's all saved there. So now that we have this, how do we access this? So what we have to do in order to access this, we have to go back to the scripts folder, and we have to tell the Python module that we have a submodule. Okay, let's go ahead and do it. So where you're going to, I like to put these extra modules right up here on top. And in order to do that, first we have to import an actual library in order to get it to work. So we'll go import tool utils. All right, the tool utils, those have been audited. And so I'm just going to create the new name. So squab equals tool utils. Say that times really quick, 20 times. Tool utils dot create module from section. So this is a mouthful. So create module from section. Okay, so what that's going to do is it's going to create an actual module from a separate section. All right, now we have a bunch of parameters that we're going to go. All right, so the first parameter is the local name of the module, and we're going to call it squab. That's the name that we're going to access this from now, because this is our squab Python module. And then we want to give it the type, so we tell it to put this in quargs, and then inside the index, type in the string type. And now what we're going to do is we're going to give the actual name of the file that we put this in, and we put this in as squab underscore Python module. And oops, I misspelled that. That's squab underscore Python module. Okay, so this is a capital P underscore Y Python module. Okay. So with that done and said, we have squab tool utils create module from section, and here we go. Python module, everything looks fine. So let's give it a shot. So now we've told our main Python module that we now have a submodule, and this is how we initialize it. Click apply. So there we have Crag. So let's go ahead and see what happens when we try to do this. Okay, so I'm going to test it in shell because we don't know what's going to happen yet. In fact, this may not even work because I haven't even tried to install it yet. In fact, let's just see what happens. So I'm going to type who.node type. Okay, and then we're going to use this obj node type category to access the node type again. So who.obj node type category. Oh, it's filling it in for me. Thank you very much, Houdini. And we're looking for, here's our node type. It's HSL demo, all lowercase. Okay, that's going to return the node type pointer to the location in memory. So that's why we didn't have to recreate it, because we're not accessing the actual instanced digital asset. We are locating the actual location in memory now. So we're going to go, okay, give us the HDA module. So HDA module. Okay, so now we have access to the HDA module. Okay, get out of here because I don't want you here. And now I'm going to access my submodule, and that's called squab. And then I'm going to access the make me function. Make me. All right, so there's our string. So here's a whole bunch of gobbledygook here, but now we're going to call the make me function, and we're going to hit enter. Oh, look at that. It says global name who is not defined. Okay, well that's a really easy fix. So I'm going to go back to extra files, and there it is. So notice here in our extra file, this extra file is just a bunch of text. It's just a bunch of, it's not even a Python script yet. So it doesn't understand it's a Python script. So we have to tell it, make it a Python script. All right, we do that by, what we're going to do is we're going to include or import who. So when we import who, the digital asset's going to go, so this is a Python script, and we want to import the Houdini Python module along with this. I see. So if we click apply, now let's see if we try this one again. Pull this again, squab make me. Up, and we got something. I'm going to hit accept just to get out of the way. And we've got Crag, and we've got our squab now. Now, regretfully, the squab is not animated, so he's not doing anything fancy. He's just kind of like laying around like a lazy clarinet player. Boom, boom, boom. Okay, but our separate module now works. So cool. We have now a separate module that is good for saying. Now we can create as many modules as we wanted to. Let's say that I'm going to go ahead and get rid of all of these. And let's open this up. Let's suppose I wanted to create another module. So here we have the squab module. And so let's call the, what's another module? What's another kind of like property type? Let's call this the Roberto Python module. So I'm going to say selection name is Roberto Python module. I'm going to say add empty section. And so now we have another Python module called the Roberto Python module. And so I'm going to copy the contents from my squab Python module, and I'm going to paste it right here in the Roberto. And so I'm going to say this is my Roberto Geo. And then the name, we're going to call this Roberto. And then for the test geometry, we're going to call it rubber toy, because that's what Roberto's real name is. Rubber toy, and then we're going to call this Roberto. All right, I'm going to click apply, and now we should be, what we have to do, we have to register that with the original thing. So here we have squab up there. So let's go ahead and register the Roberto Python module. And I'm going to say Roberto equals create from section. We're going to call this Roberto. And then the Roberto Python module. I'm going to move this over just to give us a little bit more room so you can all see that. Click apply. So we created our extra Roberto module inside of our extra files. We come over here to scripts, and inside of our Python module, we registered the Roberto script, the Roberto Python module as a submodule of the Python module. We clicked apply, and we should be ready to rock and roll. And so now let's go, and instead of squab make me, let's go Roberto make me. Hit enter. And boom, boom, boom. Roberto has now joined the party. Okay, now this is all good to find. So that's how you create multiple modules within a digital asset. Okay, so I promised that we would talk about callbacks here. Now, let's suppose that this is all good and fine typing inside of the Python shell, but this leads to carpal tunnel, or if you're a really slow typer, you're going to be 99 by the time you finish your digital asset. So let's go and implement some callbacks. So okay, let's get some button action going on here. So I'm going to go over here where it says parameters, and I'm going to add a folder right here to the root. And I'm going to change this folder name to HDA control. HDA control. All right. So I'm going to drop in a name. I'm going to go and find a button. Where's a button? Button. Okay. I know it's here somewhere. Oh, there it is, way up top. I'm going to grab a button, drop it right under HDA control, and then I'm going to call this my button. Okay, and the label, I'm just going to call my button. Okay, now what we're going to do is we're going to change the callback language. And it depends on how your Houdini is configured. Mine is kind of all wigged out. Sometimes it's H script, sometimes it's Python. I don't know which is going to show up, but make sure where it says callback script, make sure that this little symbol here, if you click on that, it's not H script. Make sure that it's Python, because it does matter how it digests it. Okay, and so you remember how what we did was we first found the type, and then we say, okay, then we call, then we called the actual function within the type, and we call the Houdini module. Okay, so that's basically what we're going to do the same thing. And here's the short term, or here's the short form of what I was trying to access earlier. So here's the code to call back. So I say who.pwd, print working directory. Okay, hm. Okay, oops, that should be .hm. Okay, that's a short form for HDA module. Bump, bump, bump. All right, and then I'm going to call my button callback function. And now I haven't written it yet, but I'm still going to call it anyway. So I'll say my button. Okay, and now I'm going to send my button a couple parameters. So what I'm going to do is I'm going to send it the quargs variable, because I love my quargs, and the quargs is going to have all my information that I could possibly want. So I'm going to send it the quargs, and I'm just going to send my path, or the path to this node. So I'm going to call it who.just pwd. All right, so that's what it's. So there we go. Who pwd hm my button quargs who.pwd. Okay, we've got that tightened in. Okay, I'm going to click apply. All right, so the callback and all that stuff was registered down here in the tags. But my button doesn't exist yet. So let's go back to the scripts and go back to our Python module and add the function for our code. So def my button. Now this one does have parameters, and so it receives some quargs, and it receives me. That's what when you put the who.pwd, it sends a pointer to me. So, ooh, that's BV button. That's not cool. Is it possible to reference the nodes in the variables? All right. Now, Binomi, I don't know how old your question is, but let me see. Is it possible to reference the nodes inside of the variables? Yes, and we're getting to that, actually. Glad you asked. What a great segue. But we're going to get to that in just a fraction, and that actually is stored inside of the Quargs dictionary. So, excellent question. Thank you very much. So, oh, there it is. Let's actually go ahead, my button. So let's go ahead and just print the Quargs dictionary. And so we're going to go print I am, and open and close curly brackets, and my quargs are, and then open and close curly brackets. And then I'm going to say dot format, and then inside of that I'm going to put me, and then quargs. Okay, so that should print it out. Okay, so hit apply, and now if we look over here to our digital asset, so HSL demo, there's my parameters, HDA control, there's my button. All right, so we have a button function in there, so let's go ahead and press my button. Okay, I am HSL demo and my quargs are, oh God. Okay, this comes out, it lists the whole darn dictionary. All right, we already know that the dictionary is kind of like, so we wrote a script earlier to kind of access the dictionary's contents. And so here it is. I'm just going to grab this statement here and copy it and go back to my Python module. And I'm going to get rid of this last statement here. Creative printing on the fly. And there we go. Okay, so what we're going to do is we're going to print I am blank and my quargs are. So let's take a look at the quargs when the quargs is called by a callback function. So we hit apply. I'll move this off to the side. And now we're going to click my button. Let's give us some room here so we can read what's going on. My button. There we go. Okay, so these are the information that is going to be accessed to us inside when we get a callback. So we're going to get a node, which shows us that we're in HSL demo 1. That's the node name. Now here's script values, but that's a little bit thing, but if you wanted to create some script values inside of the actual little function itself, you could access this. We're not dealing with that, but we are dealing with the script parm, and its location is in my button. Now, for the actual parameter itself, this tells us that my button is the parameter. So if we look over in our dictionary or in our parameters, we can see, yes, my parm is called my button. Okay, so this tells us what the parameter is and what the parameter name is. All right. Now, it also has the script or the parameter value, but in this case it's 0 because at this moment in time, when it was printed, well, it's actually 0. Now, as soon as it was the button was pressed, we got a value of 1, but since the value of 1 is no longer necessary, it went back to 0. So the button finished, but that tells you what the parameter name, the parm is, so forth. So that tells us all the params here. So that gives us a list of what all of the various callbacks are. Okay, now we've displayed what those are. So we can go and make a new button in the type manager. And so let's go ahead and as we say my button. So let's just say a new button. We're going to grab off here and we're going to say my character. Okay, make character. All right, so we've got make character in here and the label says make character. Okay. And so what we're going to do is we're going to see if this works. So we have make character and then the callback script, make sure it's Python. And we're going to call this by calling a function inside of our Python module called make character. So let's call this so who.pwd. It gives the current working location. .hm. So give us the Houdini module, the HDA module, which is another word for give us the Python. Say make character. And then I'm going to give it the quargs. And I'm going to give it me, who.pwd. All right, I'm going to hit apply to make sure it's registered with the tags and all. So let's go ahead and type this in. So here we have our codes. And we say def make character. And then we're going to get called by the quargs and me and the quargs and me. That's right. Yeah, that's all we're going to get. Okay, I got confused there for a moment, gang. All right, so who do we want to make? We can either make Craig, or we can make Roberto, or then we can make the squab. Okay, so let's just make the squab. So me is a pointer, is of course to my node type, and that's me. So I say me.hm is my Houdini module, and then say Roberto is my sub module, and I'm going to say make me. All right, we got that, and then we hit apply, and now there's my make character button. Now if I, oops, I'm going to get rid of the old Roberto. If I hit make character, uh-oh, we got a syntax error. I was expecting that to happen. I was typing way too long without a syntax error. All right, syntax error, line 27, make character, quargs, who does be. Okay, so we've got a syntax error in line 27. Okay, that's fine. Here we are, 22. Quargs, Roberto, make me, make character. Okay, I misread my thing. There is no line 27 because this only goes to line 22. Let's call this again. Invalid syntax, who.pwd, hm, make character. Oh, I mistyped my callback script. Shame on me. All right, go back over here to the parameters. And here it is. Here's my callback script for make character. And it's who.pwd, open and close parentheses, .hm, open and close parentheses, but I forgot to put the dot right in there. Syntax error, user error, apply. All right, now let's give it a shot. So go ahead and hit make character. Aha, has no attribute, function has no attribute, hm. I'm going to have to figure out more about this hm. But, so let's go ahead. It doesn't like hm. I figured it would work there. So let's see if if HDA module works. HDA module, are you going to work? Click apply, hit demo, make character. Has no, okay, so it's not working with me because I might have to check it out. There might be something wrong, but I know that if I type quargs, and then inside of that I access type as my key value pair, that it's going to give me the right information. I click apply. Now this should work. It says syntax error. Quargs type HDA quite. Now where is that? Okay. Quargs type, okay, HDA manual. Okay, so let's just see what's wrong with that. So I'm curious now. My interest is piqued. So it was print quargs type equals, open and close squirrely brackets, double quotes, dot format, and we'll go quargs, and inside of that, put type. Okay, what is wrong with you? And I might as well go ahead and comment this out because I know it's going to error anyway. Hit apply. Make character. It says line 22 is like, this does not key error. It does not like type at all. So something is going on with my quargs. I'm not calling my quargs correctly. So that's a good indication that I've got a typo here in the parameters list. So I'm going to click OK and go parameters. So we do know that this worked, right? Okay, so that worked. And so what we did was make character. So what I'm going to do here is I mistyped something in here. Oh, I know what it is. It's who.pwd and quargs. And this should be in parentheses. Yes, another typo error. So if we here open and close parentheses, click apply. Make character. Go with error type. Okay, I am just flummoxed. I don't know what I'm doing wrong. So what I'm going to do is I'm just going to copy this callback script because I know this works. And I'm going to paste this in here. And I'm just going to call this make character. Now I'm going to hit apply. Now let's see what happens. Make character type. Something is up and it is not happy. Quarg, make character, quargs me. So something is not copacetic with this function here. And I don't know what the error is here. Quargs equals, so let's see, we'll just even print out quargs. Keep it simple here. Quargs, print quargs. Apply. All right, make character. Does it print the quargs? Yes, it does. So it has node. It has script value. Parm. Okay. 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 Okay, I know what's wrong because there is no type. Okay, dopey me. We have to get the type variable because look at here, because here is an output of where our quargs are. I say key node, we got the node script, parm name, but look at here, there's nowhere information of where our type is. So what we can do is we do have a pointer to the node, and so we are going to get the node type of the node. So this is kind of nutty. Let's call this type equals me. Wait, what's is the name of that function? Oh, I'm always forgetting this. Let's see. Okay, okay. Who dot node type? Oops. Let's see what happens. Who dot node type, and we're going to send it me, and we're going to print type. All right, we've got that going. Let's see what happens. Let's see if that even works. Apply. We click make character. Node type of argument, character contrast, blah, 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 blah. In method, node type argument of type 1 character constant. No type error in method, node type. Who dot node type? It doesn't like that? Oh, okay. So let's try me. Okay, I'm really grasping at straws here. So me dot path. Okay, so that gives the full-blown path on there. So that ultimate is let's try to see if that works. Me dot path, make character. Okay, there we go. There we have the node type. Okay, now we have the information. And now we should be able to just get rid of that. And then we say type. Okay, now we have the pointer to the thing. And so let's see if this works now. Okay, hit apply, character, and there's my Roberto. Okay, to make a long story short, we figured it out. Okay. Very good. But once again, we had to use the node type, and then we had to use the full path of what me was in order to get it to work. All right. Thank you very much for your patience and allowing me to fumble around, always exploring, always trying to figure out new things. All right, so now we have that. Now suppose we have our callback. It is working. Now let's suppose that we wanted to make a variable number. So when we say make character, it just went ahead and called Roberto. But what if we didn't want Roberto? Sometimes we feel like we want Squidward. And what if we want Stosh? Or what if we want Squidward? Or we want something else? Well, what we're going to do is we're going to give a variable menu to our instance here. And so we're going to go ahead and create that. So click over here to parameters where it says make character. I'm going to click on this and I'm going to go and create a string. Remember, this can be anything. So what we're going to do is create a key valued pair. So I'm going to grab a string, drop that under HDA control, and we're going to call this make type. Okay, we'll call it character type. Character type. And for the label, character type. All right, we've got that going. And we're not going to even give a callback string because we're not going to even do a callback for that. But what we are going to do is just kind of test to see if this works. So if we have menu on there, we're going to go to use menu, and we're just going to leave it as, so we're just going to kind of test it. So we're going to go in here, and for this value, we're going to put, rubber toy. And for this value, we're going to put Roberto. And for this next value, we're going to put squab. And for this value, we're going to put in Squidward. Okay, so now we have this coming through, and it's going to have multiple parameters going that. Okay, so we have our character type. And just to make things a little bit prettier for this make character, I'm going to go over to the parameter and say horizontally join to the next parameter, apply. And what that did, folks, was look over here. If I click HSL demo, this put the Roberto button, and so if we can choose either Roberto or Squidward. Okay, so let's put that information inside of our function in order to deal with it. All right, where's my scripts? Okay, so we have make character, and we're not going to even deal with this type business anymore, but we're going to go and I'm going to go ahead and just leave that there. Well, actually, I'm going to get rid of this because we don't want to make any more Robertos than we need. So what we're going to do is I'm going to say make character equals, we're going to say me dot parm, and then it was called make character. The parm was make character. That's mark character, not make character. That's the name of our parameter. And then we are going to evaluate this. Now, we didn't actually go into that too much, but whenever, okay, what's going on here is that we're accessing the parameter that we created in here. Notice that this is a new parameter called, oh, it's character type. Okay, so I misspelled it wrong again, entirely. So it's character type. So this is character type. And so what we had to do is evaluate this parameter at the time of pressing that. So that's what we're going to do. And so it is called, it's called character type. And so we're going to say character type. And I'm going to make this character type just so I don't forget. All right, let's just see if it actually works. I'm going to go say, okay, print my character is, open and close squirrely brackets, dot format, and then I'm going to add character type. All right, so that's just going to print out whatever the character is I press. So I'm going to hit apply. And do we have any characters on here? No, we have no characters on here. So I'm going to say, okay, it's Squidward. I'm going to say make character. This is my character is Squab. Okay, that's just what I want. If I change this to Roberto, make character, my character is Rubber Toy. Okay, that's cool. So our little makeshift menu works. But notice that we did this menu by hand, and we don't want that. We want this to be dynamic. So instead of saying menu items, let's make this menu script. Ooh. Okay, so we have a menu script. And so I'm just going to go and initialize the script and say results equals, and open and close square brackets, which means is like, okay, make it an empty list. Okay, and then I'm going to say my value pairs. You know, we were creating pairs in here. You know, Rubber Toy with Roberto, Squab with Squidward. Let's go ahead and make some pairs here into one giant list. So pairs equals, and I'm going to make this a square bracket, and then let's put in the first pair, and that would be Rubber Toy. And the other one is Roberto. Okay, that's our first pair. And so let's put in another pair. And the other one is, okay, let's put this in. Crag. And actually, Crag's call name is Crag itself. Okay, so he was easy. Okay, comma. And then inside of it, we're going to create another pair. Let's call a squab, comma, and we'll call this Squidward. All right, let's have another option. All right, so let's have, let's call this Pighead. And let's call this guy Piggy. Oh, let's call it Miss Piggy. Miss Piggy. And then one more. All right, when we want the character of Tommy. And let's call this Stosh. Okay. There we have is a large list of objects. But notice that this is a list of tuples. Now, you might need to know a little bit of a difference between what's the difference between a list and what's the difference between a tuple. And, okay, very simple. A list is mutable, meaning that you can change the contents of it. A tuple is surrounded by parentheses, and it is immutable. That means it doesn't change. That's really all the difference there is. But right now, it is a list of tuples, and we don't want that. We want a flat list. So what we're going to do is we are going to convert pairs into a flat list. And here's a little kind of like tidbit I picked up here from the folks over at Side Effects. I'm actually not smart enough to come up with a function like this, but check this out. We're going to result equals item for sublist in pairs for item in sublist. So what this is this creates an embedded for loop inside an embedded for loop to list all the contents of a list. Yeah. And so let's see if this actually worked. So print result equals, open and close curly brackets, close quotes there, format result. All right, we've got that on here. All right, so here we are inside of our menu script. What's the last thing that we have to do? We have our result, and result is a flat list of elements. And it's not any tuples, it's a flat list, meaning it's all just a list, one right after the other. And we have to say return list. Okay, return, oh, not the return list, return result. Got list on the brain. Okay, this return list returns the list to the digital asset event handler, and it creates the menu based on the content that was just given to it. So here is our function. Now you could create any kind of function to generate this list. It doesn't really matter. But what we have now is the functionality for implementing and digesting this list. So let's click apply and check it out. I think it worked, folks. Like it says, results equals rubber toy, Roberto, Crag, Squab, Squidward, Pighead, Miss Piggy. Okay, notice that this is a solid list for everyone. And so Miss Piggy, and hey, this thing is working. Okay, we are good to go. So I'm going to get rid of this print because it's really annoying. But it's good to know. So we have this. So all we have to do now is just generate our character. And we already know how to do that. So I'm going to go back to my scripts. And my character is, instead of printing my character, I'm just going to comment that out. So we have our character type, And so what I want to do is I'm just going to go and just duplicate all this and put this down here. And let's actually create the character. So let's say top equals who does, because this is the top node, geometry equals create node, geo, and then let's just call this guy a, let's just call this geo. And then I'm just going to call this character. Geometry create node. And so it's test geometry. Oh, here's what I wanted to do. Here we have a character type. And so here it is. I'm going to call this critter type. Critter type equals, let's see. Oh, yeah. Single quotes, test geometry, underscore, open and close squirrely brackets, single quotes, format, and then I'm going to put inside of here character type. Okay, so we've got critter type coming through here, and it puts into the string, test geometry, all that. Okay, and let's just go ahead and put critter type in here. Critter type, and then instead of character tag, we're going to just put critter type. Critter type, and then for crag, we're just going to put character type. All right, so here we have our thing. So now we're getting our input from a dynamic variable. And now what we're going to do is create dynamic characters. So we click apply. HLS says no. Okay, I'm going to say make character. And there's the pig head. Woohoo! So I'm going to move the pig head out of there. All right, what else can we do? Let's get Stosh in here. We haven't seen Stosh. Stosh hasn't made an appearance. I'm going to click make character. And then we have Stosh. Ooh. Now, what kind of party would be complete without Stosh gracing us with his presence here? And we could do this all day. And we have our digital asset here. And we can go and let's go and grab Crag to begin back right where we started from. And there he is. All right. So as you can see, we created Python here to kind of create a quick test geometry character generator. And we never actually did. We did everything purely by code. And so as a rehash, we did most of the heavy lifting here in the scripts inside the Python module. This is where we put most of our functions in here. And then when we decided to create a special variation on that, that we wanted to take advantage of the event handler, then we created the event, and then we created a function based on a Python function based on the event handler. And we decided, we said, okay, let's create some extra modules. And so we were able to access extra modules. But before we could use those extra modules, we had to call them within our Python module and register them as submodules. We did a quick little Python script in order to create callbacks that basically called our Python function. And we, as just general use parameters, we sent quargs and the who.pwd. And we are able to create a dynamic menu by just typing in a Python script and then returning a flat list of key valued pairs. Now, what we did was we returned two key valued pairs, what we returned essentially as a dictionary. Now, this is a string and a string for each key value pair. It doesn't necessarily have to be that. It could be an integer, it could be a float. Doesn't really matter. It's our choice. So that's one of the cool things. And this is registered and recreated and recomputed with every access to the digital asset. So that is the content of what I wanted to go over today. Thank you very much for your attention. Thank you very much for your questions along the way. And there's some very good questions. And next week, I plan on going over a few more digital asset special sneaky tricks that you may not be aware of. But this pretty much is how Python integrated for this, and it's really dynamic. Now, we already did the action state a couple of weeks ago. Look for that to actually create some actual interface for the action script. Now, that's kind of like a whole deal, and I'm glad we've already done that itself. And so that kind of pretty much that. So next week, we're going to have just a little bit more information. If you have any requests for any topics for what me to cover in Houdini, please feel free to drop me a line and make your request. I love hearing requests, and I will most probably try to figure out what I can in order to acquiesce to your request. And for all those folks in the Central Florida region, remember there is a Houdini users group meeting tonight at 7 o'clock, and I posted in the chat the location for the meetup location. So if you want to drop in and join us, hell, even if you are somewhere not in the Central Florida region, I suppose you can join us as long as your name isn't like Fart Bubbles or Making Merry or something other obscene that I've seen lately. Please come and join us. Well, thank you very much for joining me. I will see you folks again for Houdini Secrets Live next week. If you like what you saw, like this channel on YouTube. Check me out on Facebook. That's Chris Rhoda. Or check out the Houdini Users Group page on Facebook. Or check me out on LinkedIn at Chris Rhoda or TechArt EDU. Thank you very much, and I will see you again next week.